Good afternoon everyone, my name's Aaron Kennett and I'm here to talk about my project, which is efficiencies in setting up of high voltage circuit breakers. I've worked at National Grid now for 8 years and my area of expertise is in high voltage switchgear. Recently, Ofgem, if you don't know, they are a government funded regulator and they are there to help regulate monopoly businesses, National Grid obviously being one of them. They've recently introduced RIIO T1, which is price control. So they're pretty much encouraging people to reinvest in the network instead of just taking money and giving it back to shareholders. So as it says on the slide here, that as employees we've been asked to think of innovative ways to save money and costs, and this is why I've chosen to build a jig to help my company build towards this. Just a bit of background. This is what my project is based around. It's a Fraymar air blast circuit breaker. It's operated here with high pressure air stored in the tanks, and it extinguishes the arc through the main heads at the top. It's all driven around an air engine and drive linkages which go along and up and down each phase. So this is what my jig is going to be based around. Currently, the current problem we've used, as it says on the slide there, most of this equipment was installed in the 1960s and the majority of it hasn't been modernised. So the refurbishment centre is setting up various projects all over the country to try and do this, and that's why I've decided to try it myself. As you can see, old techniques is just literally ruler and using your eyes, and as it says up here, if a craftsperson starts the job and then has to leave the job or goes off sick, it's very hard for someone to take up where they left off and actually understand where they were taking their measurements from, what point they're up to, and so forth. So yeah, this is what the jig is going to aim to eradicate. Main benefits of the jig: save times in setting up the circuit breakers. The aim is for the jig to enable craftspersons to set up the measurements required with increased accuracy, increased productivity with the time saved in setting up the circuit breaker, set a standard for craftspersons around the country, and enable the setting up of the Fraymar circuit breakers to be more easily taught and passed on to new starters and apprentices. So Project Implement, this is when I took my rough sketches up to the refurbishment centre, where we actually have designers, and yeah, I went through my ideas with them and pretty much used their experience to pick their brains about how I could do it. We took various measurements off schematic drawings and pretty much just their knowledge. Couple of bits my logbook highlighted that we couldn't actually deal with in-house. We had to go to Precision Engineers to produce a CAD drawing. They also had to make the pointer tool for us because that was something that wasn't be able to done in-house. So again, I'll go on to it later, but this was identified in my logbook with my weekly entries. The main way I kept track of it, after my meetings with the refurbishment centre, Scott, the refurb manager, allocated a toolmaker 9.5 hours a week. So I divided that up into the 7 weeks I had during my build stage. And again, I did weekly entries about what I had to achieve, which various components I built, and then also I did a cost breakdown weekly until I got to my end totals. So yeah, it was a really good way of keeping track if I was on time with my spending. The finished jig, which you can see here, everything went to plan with it. Pretty good success. Like I said, the only thing I had to outsource was the pointer. Again, that came back from Precision Engineers and they did a really good job with it, so pretty happy with the end product. Evaluate, so this was the live field testing, and this was probably the most beneficial activity I carried out during the project, as I've got about 8 other people's input onto the jig and their thought processes, so 8 heads are normally better than 1 anyway. So I've got this video. Oh, what's up with this, Tom?
No idea.
What does that mean? Oh right, well this is a video here anyway, and it's showing that this is the air engine operating I was talking about earlier, and the main drive rod drives up and down here, and the pointer tool is assembled on top of the jig. So that actually goes on top of a pin, and all you'd need to do would be press down on this jig, and when it hits the centre point of the pin, that enables you to know you've reached the desired measurement. There's no need to use rulers, there's no need to mark, there's no need to scribe. All you have to do is line the bottom of the pointer up with the centre poppet of the pin in the main stack. So evaluation, the jig, like I said, was field tested. All the measurements are recorded in the National Grid work spec, which is what my project had to run to. All the measurements involved were achieved by the jig and were within the tolerance allowed in the spec. And the main way I did my evaluation is I timed setting up the circuit breakers, both the traditional way and the new way using my jig. And I shall talk you through the following results as follows. So mainly, my main aim was to achieve cost and also man hours. This was the cost just using one jig, so I saved £426. Oh sorry, that was how much the jig cost, £462. The savings made were 22 man hours and 375 quid. So the first jig only actually cost £86.71. So now every time it's used after that, everything's going to be profit to National Grid. So I'll put in here, I'd expect the jig to last for at least 5 years and be used up to 12 times a year. So over a year, we're looking at about £22,000 in savings and 1,320 man hours over the year. So it's a massive saving. Again, I had a nice video for you here to show the circuit breaker going back into operation, but it doesn't look like the technology is going to work today. Maybe I'll show you all after on the laptop or something. So project conclusion, this was really where my main learning point, just to recap, that I did actually achieve everything I set out to do. So I've achieved an innovative way of saving time and money. I've saved, the aim is for the jig to enable craftsperson to set up with increased accuracy, which again it is, it's not reliant on any sort of measurements, it's all just done on site. I've increased productivity because I've saved all the man hours, and again I've managed to set a standard now. It doesn't matter where you are around the country, the jig's going to be the only way to do it. My main learning points I'd like to cover, which came from my live field testing in the earlier slide, was some of the feedback I got from some of the craftsperson is that if we actually had 3 jigs on site, we wouldn't have to move that one between each stack, because currently we had to move it between each stack. So the main learning point for this would have been spending more time on formulating my project instead of rushing into the development and build stages. I'd have taken a bit more time thinking about the problem I was trying to solve. I actually reckon I would have thought of it myself, and greater savings would have been achieved in the long run. But overall, I'm pretty happy with how the project went. I think making 3 in the time scales probably wouldn't have been achievable, but I'm definitely going to go away and approach National Grid and recommend that I build 2 more.
Thank you very much.